Hello, it's Dumplet here. Here's an item on algebra. Here we're given with a parabola with equation y equals x squared. Choose any point P on this parabola. Find the minimum value of D, where D is the distance from point P to point Q, which has coordinates at 3, 0. Credits to the Art of Problem Solving community for this item. As usual, pause this video if you'd like to give this item a try, but if you're done, let us dive into the solution. I'll be providing two solutions to this question. One, we're going to use a purely algebraic approach, and the other one, we're going to use calculus. Let us start with first the algebraic approach. So for the algebraic approach, it is kind of expected that we're going to use the distance formula, since D, the distance between 2 points, is easily acquired by the distance formula. So, well, I can let any point P be x comma x squared. Now take note, any point is represented by x, y, but we know that y equals x squared because that's the equation of the parabola. That's why we have x squared to be the coordinates of point P. So all we have to do is just get the distance between P and Q. Now, by the distance formula, that will be simply equal to the square root of the square of the change in x, so x minus 3, and then we square it, so that's the change in x squared, and then the x to the fourth comes from the change in the value of y, which is x squared minus 0, and then squared. That's why we have the x to the fourth here. So if we want to get the minimum possible value of the distance between P and Q, the D over here, I guess all you have to do is just simply find the minimum value of whatever is inside the square root, because this we just have to get the smallest value of whatever is inside the square root, so we can get the minimum possible value of the value of D, obviously. So expanding this is going to give us x squared minus 6x plus 9 is equal to x to the fourth. Now here we arrive at a problem, because this is technically a quartic expression, and there isn't really a nice way for us to get the minimum value of this one. Now we can obviously use calculus here and make our lives easier. Take the first derivative and then solve for the critical points. But that's not really the CA that we need. We don't want the calculus. But instead we can try to use Cauchy. So Cauchy-Schwarz inequality. But we can try to use the Cauchy-Schwarz inequality, but again, it's not the most obvious of things. So by the Cauchy-Schwarz inequality, we can try to write this expression down as x minus 3 squared plus x squared, and then square it. And right, the next term over here is not really the most obvious thing in the world. So negative 2 squared. Again, these are just kind of a forced algebraic solution, but well, whatever works for us. So by the Cauchy-Schwarz inequality, the following inequality is true. So this is the value that we kind of want to get the minimum value of. So the square of x minus 3 plus the square of x squared times the square of negative 2 plus the square of 1, it's going to be greater than or equal to negative 2x plus 6 plus x squared. Now, so the minimum value of this one just kind of relies on the minimum value of this one. So we can kind of write this down as x squared minus 2x plus 1 and then plus 5. Now since we know that x squared minus 2x plus 1 is the square of x minus 1, we know that the minimum possible value will happen at x equals 1. Again, this is kind of a forced algebraic solution because it is not really obvious to get the square of negative 2 and the square of 1 to use for the Cauchy-Schwarz inequality. Well, so this is the reason why a purely algebraic approach might not be the best thing to do in this item, but instead we're going to use our knowledge in calculus, so dealing with graphs and maybe including the tangents, because if we try to use calculus in this item, we can try to check the slope. So for example, we are still going to use the fact that P is at x comma x squared, but what we're going to do here is to realize that, well, since we've kind of discussed back in the days in high school that the shortest distance from any point to a line is the perpendicular distance. So we can use this fact by checking the tangent line at a specific point x. So for example, at x, there will always be a tangent line at point P, for example, and we know the slope of this line. The slope of this line must be 2x. Now, how do we get 2x? Take note that we have y equals x squared, which is the equation of the parabola. We're going to take the first derivative, and that's going to give us 2x. Again, just bring the 2 down and then subtract 1 in the exponent. That's the power rule for calculus. So the slope of the tangent line would be 2x. So what do we have to do with the slope of the tangent line? Well, we know that if I connect P and Q, so this segment, if I connect P and Q, this will have a length of D. But what's more important is that this segment is going to be perpendicular to the tangent line at point P. So, well, we have a pair of points, and we will now know the slope because it's going to be the negative reciprocal of whatever slope the tangent line has. So we would know that negative 1 over 2x, that's negative reciprocal of 2x, that should be equal to the slope. We can use these 2 points to find the slope, x squared minus 0 divided by x minus 3. So all we have to do is solve for x over here. So x squared minus 0, that's just x squared, as you can see here. So it's just a matter of solving for x. So let's multiply both sides by cross multiplication. Negative x plus 3 would be equal to 2x cubed. Moving everything to one side, 2x cubed minus x plus 3 equals 0. And all we have to do is find the values of x that work here. Now, luckily for us, a little bit of trial and error and just kind of using the rational root theorem, we realize that x equals 1 is a solution, because 2 times 1 cubed, that's just 2, then plus 1 minus 3, that is indeed equal to 0. So let's try to just check if there are any other solutions. So let's try to factor on the left side of the equation. So I'm going to use synthetic division here, and to find the other factors and the other roots if there be any. So alright, the other factor based from what I got from in my synthetic division, so aside from the x minus 1, which is a factor because we know that 1 is a solution to this equation, so x minus 1 times 2, 2, and 3, it gives me 2x squared plus 2x plus 3. So let's just try to check if there are any other solutions. Now, it is easy to check the discriminant here because, well, 2 squared, so that's b squared, minus 4ac, that's going to be 4 minus 4 times 2 times 3, that's 24, and this discriminant is negative. So we're not going to have any more solutions, therefore we can easily conclude that x equals 1 must be the only thing. Alright, now that we have x equals 1, all we have to do is substitute it back into point P. So now that we know that x equals 1, point P must be at 1, 1, so that the value of the distance, the length of p cubed, which is going to have length d, it's going to, we can get d by the distance formula. So the square root of 3 minus 1 squared plus 0 minus 1 squared, that's just going to be equal to the square root of 3 minus 1 is 2, so that's 2 squared, that gives us 4. 0 minus 1 is negative 1, squaring that gives us 1. So the value of d should be square root of 5. And this will be the minimum value of d, which is going to be the shortest distance from point Q to the parabola with the equation y equals x squared. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye!